everyone. Today, me and my partner will present to you guys about liquid helium. So my name is Nur Afika binti Muhammad Indra Alinsah. My matric number 197955. Okay, what is liquid helium? So basically, liquid helium is the element, the chemical element exists in a liquid form only at the extremely low temperature of -269 degrees Celsius or about 4K or -452.2 Fahrenheit. Okay, so liquid helium have four properties, which is critical temperature, boiling point at 1 atmosphere, minimum melting pressure, superfluid transition temperature at saturated vapor pressure. Okay, so for boiling point and critical point, it depends on which isotope of helium is present. As we all know, the common isotope is helium-4 and helium-3, and these are the only two stable isotope of helium. So next, um, on 10 July 1908, helium was liquefied by Dutch physicist, which is Heike Kamerlingh Onnes. And then after that year, liquid helium was used as cryogenic refrigerant, and then it also used commercially in MRI, NMR, and uh, experiment in physics. For MRI and NMR, this will explain more by my partner. And then next point, in order to produce liquid helium, the temperature must be low because at low pressure, the attraction between the helium atom is weaker. Next point, um, the effect of quantum of mechanics also will reduce interatomic attraction. Therefore, if the distance increase, the interatomic forces in helium will reduce even more. Next slide. Because due to very weak interatomic forces in helium, this element remain as in liquid at atmospheric pressure all the way from its liquefaction point down to absolute zero. Next point, under very low temperature and great pressure, liquid helium will solidify. And then for this point, for your information, liquid helium-4 and helium-3 are not completely miscible. At below than 0.9 K, the mixture of two isotopes undergoes phase separation into normal fluid that floats on a denser superfluid consisting helium-4. Next point, at low temperature, which at superfluid phase, it reaches with helium-4 and contain a little bit of helium-3 in solution. That's all from me. So I will pass to the next presenter.
Okay, hi. Okay, my name is Nurfaiza Tuniza binti Khairul Anwar. My matric number 196247. So I will explain about application of liquid helium. Okay, like you see, okay, this is an example of application of liquid helium. First, we use the liquid helium in magnetic resonance imaging MRI. Second is nuclear magnetic resonance. Third is magnetoencephalography. These all is a superconducting magnets that use liquid helium for cooling. So next slide. Next slide is okay. First I will explain about magnetic resonance imaging. So what it do for our daily life. So this MRI, it scan our body, patient body by using a large magnet, radio wave, and a computer to create a detailed cross-sectional image of internal organs and structures. This machine, MRI, usually the at hospital to scan the patient body to see our organs, anything to see in the patient body. So this MRI scan, it's different from the CT scans and X-rays because it does not use potential harmful ionizing radiation that can affect our body. So next, liquid helium used is in MRI machine. It's to cool down the superconducting magnet to the temperature below 415 Kelvin or negative 296 Celsius, which is the part of the MRI scanner that generates high resolution image of the human body. Okay, so in MRI scanner, there are coils, a magnet, and wires that conduct the current. Okay, in order to function, MRI scanner also require a coolant that will give the magnetic coils in the scanner superconducting properties that allows the electric current to flow through the low resistance coils, enabling the generation of high intensity magnetic fields. Okay, for the next slides. Next slide is I will show you about nuclear magnetic resonance or NMR. Okay, for this NMR, usually they use this for research or they use in laboratory for chemical like to determining the content and purity of a sample for its molecular structure. So, like example, NMR can quantitatively analyze mixtures containing known compounds. So, this nuclear magnetic resonance (NMR) is based upon the measurement of absorption of radio frequency radiation by a nucleus in a strong magnetic field. By using liquid helium for cooling to extremely low temperature, this strong supermagnetic field can be developed. Absorption of the radiation causes the nucleus spin to rearrange or flip in the higher energy direction. After absorbing energy, the nuclei will re-emit the radio frequency radiation and return to the lower energy state. So basically that purpose to nuclear magnetic resonance. So next slide. Okay, for the next slide, this is for the last application in liquid helium, which is magnetoencephalography. It's quite hard to pronounce that name. So this basically this magnetoencephalography, okay, I will call it MEG. This MEG is for measure of brain function. It's to measure our brain, and this MEG has a very high temporal resolution, which is it also has a good spatial resolution. So this MEG usually combined with MRI, so brain to get a good structure perspective. This combination of MEG and MRI is called magnetic sources imaging, which is MSI, another combination from the both MEG and MRI. So this MEG record magnetic fields generated by electric current in the brain. And electric current is always associated with a magnetic field perpendicular to its direction as per the right hand rule. The magnetic permeability of biological tissues is almost the same as the empty space, and so the magnetic field is not distorted by scalp or skull. However, the magnetic field diminishes as 1 over r cubed with the distance of r. So, to record this, magnetic field present a unique engineering dilemma. There are two basic issues. One is to record these small magnetic fields, and the other is to shield out the Earth's relatively stronger magnetic fields. The technology that have record this magnetic field is superconducting quantum interference detector, which is like a highly sensitive magnetic field meter. So to maintain this superconductor, one needs to provide an extremely cold environment, which is it using liquid helium, which is only 3 Celsius, 3 degrees Celsius, about absolute zero, which is negative 452 Fahrenheit or negative 270 Celsius. So to the external magnetic noise, the MEG, is how this MEG is inside a magnetically shielded room because this MEG is external, it's a bit noise. So the actual sensors recording magnetic fields are magnetometers or and gradiometers. There are two types of gradiometers, which is axial and planar. Magnetometers provide the best signal and are more sensitive to deep brain sources, but are also more sensitive to competing magnetic noise. So, gradiometers are better at noise reduction. So, the for the next slide, this is for a picture that shows how the MEG looks like. It scan or measure our brain. So that's it from me. Okay, thank you very much for presentation about liquid helium.
Thank you, Doctor.
Thank you, Doctor.